Pre-statistics. Graphing quadratic functions in the vertex form, Part 2. Lesson objectives. Graph a quadratic function in vertex form. Find the domain and range of a quadratic function. We'll begin with an example. Example 7. Sketch the graph of f of x equals 3 times the quantity x minus 1 quantity squared minus 2. Solution. Step number 1, we want to graph our basic x squared function. The next step, we want to graph x squared with the value of a, and in this case a is 3, so this is a vertical stretch by a factor of 3. For example, when x is 1, I take 1 squared, 1 times 1, which is 1, times 3, so 1, 3 is on this graph. When x is 2, f of x will be equal to 12, so on and so forth. Next, we want to do our horizontal translation. So in this case, h is a positive 1, so that means we take our 3x squared and we translate it 1 unit to the right. So the vertex now is at 1, 0. Next is the value of k. K is a negative 2, so that means we take the graph and we translate it 2 units down. So we have our graph. And if we look at the values of a, h, and k, a was 3, so that's a vertical stretch by a factor of 3. K was 1, so that's a horizontal translation to the right 1 unit. And k is negative 2, so this is a vertical translation down 2 units. The value of h and k affect the vertex. The vertex in this example is the coordinates 1, negative 2. So it turns out to be the value of h and the value of k. Let's do another example. Example 8. Sketch the graph of f of x equals negative 2/3 times x plus 5 quantity squared plus 4. In this case, a is a negative 2/3, h is a negative 5, and k is 4. Solution. We first begin with our x squared, our basic quadratic. Next we want to do ax squared, and a is 2/3 in this case. So when x is 3, we take 3, we square it, we get 9. 9 times 2/3 is the same thing as 9 times 2 divided by 3, which is 6. When x is 3, y is 6. So if we look at the relationship here between x squared and 2/3 x squared, 2/3 x squared is wider. Next, since a is negative, we need to reflect it across the x-axis. So we have this. Next is h. So since h is a negative 5, we translate 5 units to the left. And last is the value of k, which is a positive 4. So we take this parabola and we move it 4 units up. And we have our graph. So if we look at the values of a, h, and k in this example, we had a vertical stretch of 2/3. Because it was negative, it was also a reflection across the x-axis. We had a horizontal translation to the left, 5 units, and a vertical translation up 4 units. And the vertex for the final graph is negative 5, 4. Again, the value of h and k. Example 9. In this example, we're going to work backwards. Instead of having an equation and graphing it, this time we have a graph and we want to write the equation of the graph. We know the vertex, 2, negative 5, and we also know a point, 0, negative 3. So that's the y-intercept. So if we have these 2 points, the vertex and a point, we can write the equation in vertex form. Solution. So we're going to use the vertex form. We know h and k. H is a positive 2 and k is a negative 5, and we got that from the vertex. Now the only thing that we need to find is the value of a, and we're going to use that point as 0, negative 3. X is 0, y is negative 3, so we plug in negative 3 for y, and we plug in 0 for x. Now we follow the order of operation. 0 minus 2 is negative 2. Square it, and we get 4. So this term becomes 4a minus 5. Then we add 5 to both sides, and we get 2 equals 4a. Solving for a, we divide by 4, and we see that a is 1/2. Substituting a back into the formula, we have the equation y equals 1/2 times the quantity x minus 2 squared minus 5. And we are finished. Lesson objective. Translating graphs. Property. The vertex of a quadratic function in vertex form, f of x equals a times x minus h squared plus k, is the point h, comma, k. We saw that in the previous 3 examples in this video. Example 10. Sketch the graph of f of x equals negative 2 times x plus 6 quantity squared minus 2, and find the domain and the range of f. So this is our first example where we're going to find the domain and the range of a quadratic function. Solution. So if we write this in vertex form, we need to see, since this is a plus 6, that means h must be a negative 6. We see that k is a negative 2, h is a negative 6. If we sketch the graph of y equals negative 2x, then we translate the graph 6 units to the left because h is negative. Since k is a negative 2, we translate the graph down 2 units. So here we have a table of values. Here we have our graph. So this is negative 2x squared. And then from that graph, we do h, which is 6 units to the left. Then k, 2 units down. So that is our vertex now. This can be verified using the graphing calculator. So for our domain, that's the values of x, and we can see that any x value will have a spot on this red parabola because the endpoints are going on forever. But this vertex is a maximum, so that means these values up here for y will never have a spot on this graph. So this is all numbers up to y equals negative 2. So the way we write the range is we first start with the smallest number, which in this case is negative infinity, and we keep going and going till we reach the maximum, and that occurs at negative 2. Let's do another example. Example 11. Sketch the graph of h of x equals 1/3 times x minus 5 squared plus 3, and find the domain and the range of h. Solution. We sketch the graph of 1/3 x squared. Since h is a positive 5, we translate the graph 5 units to the right, and since k is a positive 3, we translate that graph up 3 units. So let's look at it visually. Here's our graph of 1/3 x squared. We first have to translate it 5 units to the right because h is 5. Then k is 3, so we go up 3 units, and that's our vertex. So when we do our domain, we want to know what x values are on this graph. And we can see, because this is going on forever, all the x values will have a spot on this graph. For the range, the y values, we see that the vertex here is a minimum. So this is the smallest y value, so all y values below this are not on this parabola. Therefore, they will not be part of the range. So this is a minimum, and the maximum is going to be a positive infinity. So we say the domain, we can write it this way, is all real numbers, and the range Again, we start with the smallest value, which in this case is 3. It can equal 3, so that's a bracket. And then it goes to positive infinity. And this can be verified using the graphing calculator and a table of values if needed. Thanks for watching.